Hi, thank you to Outlyer and to David and Frank, and thank you guys all for coming. If you ask why we need to talk about performance, the reason is we are changing a lot of things. It's really exciting. It's containers and Kubernetes and meshes and all kind of interesting things, but ultimately we still need to make sure that the page loads when the customer goes there. We need that engagement, otherwise customers go away. And as the technologies are changing and we're changing the tools, some of the older ways of finding performance and tuning applications for performance no longer work. And I will tell you why this is what the presentation is about. So why am I going to even talk about it? Why you should listen to me? Well, first, my day job is to improve performance of microservice applications for customers, and we use machine learning to make that. And there's a good reason, and I think you'll find out why. It's not just a cool word. Before that, I was actually one of the people responsible for making things as bad as they are by setting up cloud and just all ways of doing provisioning and deployment using APIs instead of runbooks and humans. That created its own set of problems as we're all experiencing. One of the lessons learned is we had some DevOps customers before even the term was actually coined, and I discovered that developers really hate carrying pagers. Don't know if you would agree with that, but it's there. So I have been in this space and specifically work on performance optimizations. Just a show of hands, how many of you run microservice architecture applications in production and monitor performance? Okay, and have processes for improving performance? All right, awesome. Then I think I am in the right place. All right, just very quickly, how are microservices different? Why is it that we have to change something here? And then I will introduce 5 levels or 5 ways of tuning performance and optimizing. And then I have a slide with useful tools and links that can help you get to the last handout. So first, I want to unpack the title a little bit. So performance, okay, the golden signals, throughput, response time, error rate, well, all of the above. All of these things have to be there. And what does optimization mean? Well, we need to reach an optimal value. And I'm missing big pieces here, and I'm omitting them on purpose. Things like CDNs, customer browsers, and all of that. I'm focused only on the actual service backend, whatever it's performing, whether it's a SaaS service or whether it's an enterprise application. So how is microservices application different, or at least with respect to performance? When you look at the number of entities, a traditional application, 2-tier or 3-tier application will have 2 or 3 tiers. They usually run on the same server in many cases. So it was really easy to just put as much CPU and memory as we can put on it, and then the kernel is going to dispatch and handle all the resources. Not so with microservices. Microservices, anywhere between, 5 and sometimes 100 services are involved in serving a single request. So a lot more entities, and they don't happen to fit on the same machine. But it actually is worse, right? Is that dynamic assignment of resources that can happen on a single server cannot possibly happen on clusters of computers, because you cannot very quickly move the CPU from one machine to another. Ever-changing code base. So why is that a problem? Well, because we change the code that we're optimizing, the performance that we're changing the algorithms, putting in new image improvement algorithms, all kinds of new interesting things, or doing config changes. And again, whether you subscribe to that particular value of the graphics or the graphic or not, we are releasing between 10 and 100 times more often than we used to. Now, why is that also bad? It's not only your code. There's also third-party libraries that you use, and frameworks, and you Java people know what I'm talking about. And the underlying OS changes as well. We had some really surprises with the Spectre vulnerability fix that really changed the optimal performance point for some apps. Then in cloud deployments, you don't control your hardware, and the kernel and the storage, and also the versions of the libraries. Again, if you subscribe fully to the CI/CD, you may actually be upgrading daily. So there's a lot of code that's changing under you all the time. So when you combine this, when you have 10 times to 100 times more entities that you need to schedule and tune, and you're releasing them 10 to 100 times more often, the numbers become really, really big. But that on itself is bad enough, but we can throw more people, right? Well, no, because to optimize an application, it takes, between 2 weeks and 2 months, if you're lucky. However, your code changes every day. So whatever you optimize is already out of date. So what do? Do you put the old version, or do you run optimal? So it gets really messy, and you can't continue to use it. It's essentially broken. Well, what should we do? Well, nothing. Why should we do anything, Peter? Go home. We have our jobs forever, right? Or we can just go back to monoliths and waterfall. It worked really well for so many years, so why not do that? Or we can just live with suboptimal performance because it's so cool nevertheless, right? No. This is a problem created by machines. Cloud is essentially machines doing deployments instead of humans, right? And my premise here is that machines can help us fix that. So, 5 stages of performance optimization. I put those as stages because it kind of sounds nice, but they're really not stages. Some of them you can use together. You don't have to sequence them in time. So first, and the obvious, do not optimize. Do nothing. Why? Well, because your application may not need it. In the early stages of your application, you probably don't need that. It's all about, does the application work? Can you get customers for it? So you may not need it right away. Just if you want to be able to scale, though, design it in a way that it can scale out. And you don't have to do it all up front. You can be agile about it. Just make sure that you don't do something that will prevent scale out. It's really easy. When you need to scale it up, it's really easy. Just add more resources. They're cheap, much cheaper than the engineers that would otherwise sit there and improve things little by little. Invest in good scale out. You can't believe how many of our customers do not have automatic scaling up and down. They scale out. They have hundreds of instances, but they just don't. They're always there. And then obviously, always keep headroom because you never know when you're going to get more traffic. So how long should you be doing this? If the resources start getting too expensive, you will notice it. Your CFO will come and tell you about that. Your response time on single request becomes too high, so horizontal scaling doesn't help. Or you had to fix that twice. The first time when you fix it, it's okay. If you fix it second time, then our engineer and DevOps culture requires that we actually improve it. So what is next? Golden rule, monitor your performance for your production application. Figure out what are the key metrics that you care for and find the easiest way you can measure them and visualize them. Again, don't do too much. Many tools, they have the ability to vary. With a few clicks, you can add hundreds of metrics that you can now measure. You really don't need all of that. They're useful when you need to troubleshoot something, but pick the ones that you really care for, and then you can measure that. When you see bottlenecks, then you can find them out. They show up, and you can manually watch it, or you can start setting up triggers and notifications. So how long can you run in that mode? I mean, it's much better than before. You still have visibility. You know when things go bad. It's not customers that call you and tell you it's bad. You get too many services, so being able to watch them doesn't really work anymore. Changes in performance are happening too often, and they're not bugs, they're real. I changed the algorithm, and then all of a sudden the performance changed significantly. Or when you're ready to push that problem into the developers. In any case, you keep monitoring. Once you set it up, just keep it on. It's really helpful. Next one is to actually build a performance test suite for your application. and make it part of your running, and make running it part of your CI/CD pipeline. So typically this will be something you'll run in a staging environment. You can use existing, there's a lot of good load generators, or you can capture production traffic and replay it, or you can build your own super custom load generator that works only for your application. Doesn't matter how, make it easy, make it repeatable, which is really important. When you measure more than once, make sure that you get similar values. And then make sure that through deployments, through part of your CI/CD pipeline, what Neil is going to talk about, that if you do essentially performance regression, you have new code, make sure that this code meets the performance that the previous release needed it. Roll it back, push it to the developer back and say, no, it's not good, fix it. But have a way of releasing nevertheless, because if your CEO tells you you have to release today, you will release today. When to stop, again, resources are becoming too expensive doing it this way, or the developers really start hating you for making them do that at the deployment stage. Now, stage 4, this is more of the classic approach, APM. It's a very human-intensive process, but sometimes it's the only one that works. You have to instrument your code, language-specific libraries. You guys have done that, but it requires a dedicated team for a good amount of time to be there. It's not something you can just do among other things. At least that hasn't been my experience. Make sure that when there are successes in this, you broadcast them to the whole team so everybody gets on board in doing that. That is really important to make this successful. And even though it's not a complete fix, but this is sometimes the only way that you can improve code. The only way, if all the other tweaks and everything else that I talk about doesn't work anymore, then you have to fix code. So this is your only way. You get visibility into your code paths, and I'll talk a little bit about some tools that you can use for that. But this is the only way to improve code, to figure out where the bottleneck is and do code changes to fix it. We don't have machine learning that can write code yet. So this is the way to do it. You can keep doing that. Again, it's very time consuming, so you choose when to apply it. You definitely should stop when you're doing a big migration. Let's say when you're moving to microservices, you probably don't want to be doing that in parallel because too many things are changing. But once you have it and you have the instrumentation, it is a good thing to keep, even if you're not using it all the time, but it gives you the ability to improve performance with code changes when you need it. And then the ultimate, automatic tuning as part of your CI/CD pipeline. So there are a lot of knobs that are not code. You have things like resources, CPU, memory, or VM machine type, right? You have things like Java configuration, like which garbage collector to use, what are the parameters. Again, all of you who have done Java know that there's so many different parameters, and they do make a difference. So I'll just give you a few examples. Virtual machine types can give you up to 2x improvement in price-performance ratio. So for double the price, you can get 4 times the performance. That's something we've seen. And then on Java specifically, for Jenkins, going to, let's say, the first garbage collector can give you up to 3 times performance improvement. However, if you try to do that on Jira, you actually get 30% degradation. So it's not a one-size-fits-all. It is something that it may be different for your application and may change over time as you use different libraries and different algorithms. So lots of different things that you can tune, and I have a link to a presentation that lists even more of those that you guys can use. Try different values, and you can do grid search, you can do heuristics, or you can use some form of machine learning to try and navigate through the set of spaces. And then you can also insert this either in staging, so it's part of the CI/CD pipeline or more of the integration part, or you can put that as part of your canary mechanism. So you try this, you tune your canary, and then once you're happy with it, you let your deployment system, your Jenkins or whatever you use, propagate that performance benefit to all of your instances. Obviously, all of you use rolling upgrades and no downtime, right? All right, and when to stop? Again, this is a continuous process. It is there all the time. It doesn't require human assistance, so it always works. These are a few links for the different stages, the types of tools, and some of the names of the tools. I will post the slides, and obviously Outlyer should be on that list. So very easy to improve on it. It's not exhaustive. The Netflix link on stage 5 is also really good at having the different parameters that you can change in the operating system or in the underlying kind of middleware values that you essentially get performance for free. You make some tweaks in kernel parameters, all of a sudden you get a performance boost. That is what I have for you. Do you guys have any questions? All right, thank you very much. I will be here. Yes?
Can you skip stages? Is it possible to skip stages, or is it all serial?
Yes, you can certainly skip stages. As some of those are stages, and some of these are things that you can do or not do. They are kind of you can do in parallel as well.
Okay.
But in terms of level of maturity of how you think about performance optimization.
Thank you.
Thank you very much.